Hi everyone. So in the last video we analyzed our EM wave in free space and in lossless dielectric. Now we are going to analyze it in lossy dielectric. So if it is lossy, then sigma is not equals to 0, that we have already studied. Certainly our region will be charge free region, our medium will be charge free. Sigma is not equals to 0. Now what about sigma? Is it too high? No. Is it too low? No. It is some decent value. I will write decent. Sigma is some decent value. It is not near to 0. It is neither near to infinity. It is somewhere in between. Okay. So I am writing sigma is some decent value. So this is like a general medium. Like I will derive the expressions for sigma equals to finite. Then I can put sigma equals to 0 as well. I can put sigma equals to infinity as well. If I put 0, then what it will be? Free space, or you can say lossless dielectric. And if I put infinity, then what it will be? Conductor. So now for a general medium we are analyzing. A general medium where there is sigma is not equals to 0. A finite sigma is there. So our Maxwell's equations will change now. For free space and lossless dielectric, Maxwell's equation were same. But now it will change. Mu is mu naught mu r and epsilon is epsilon naught epsilon r, that you already know. So now they will change. Why they will change? Because this will be non-zero. So this guy will come in action. So basically these were our equation. Here del dot es, here we had rho v by epsilon naught. So that rho v is equals to 0. So this is equals to 0 only. So these were the equation. There is no change in these two equations. Del dot E is equals to 0, del dot H equals to 0. But this equation got changed, right? And can I write it down in this manner? I am taking ES as common. So I can write down in this manner as well. Okay. So now these are our equation. The derivation will be exactly same. Only a few different things will be there. That only we are going to write down. Otherwise, you can just refer to the previous video. Ditto same derivation is there. Just a few changes will be there that we are going to write down. So this is the first equation that we put, del cross ES equals to minus j omega mu HS. Then what we do, we take curl on both of the sides, then we get this expression. Then this guy is equals to 0. This guy is equals to 0. And in place of this guy, del cross HS, we are going to put this expression now. Sorry, we are going to put this expression. What is this expression? Here sigma will also come in action. Sigma plus j omega epsilon ES, right? So now this guy becomes 0. So this negative and negative sign cancels up. So here you will get del square ES minus j omega mu into sigma plus j omega epsilon ES. Now this term, this complete term is taken as gamma square. What is this? We have taken this as gamma square. Gamma square is equals to j omega mu sigma plus j omega epsilon. So from here what is the value of gamma? Gamma is under root j omega mu sigma plus j omega epsilon. And what do you call gamma? Gamma is your propagation constant. What it is known as? Propagation constant. So we will come back to the derivation, but first let's understand about gamma. First let's understand gamma. What do you mean by gamma? So gamma is equals to alpha plus iota beta, or j beta you can say. This is what I am assuming. This was your gamma square. Gamma square was j omega mu into sigma plus j omega epsilon. If you can remember it, try remembering it. If you can remember, try remembering it, because this is an important expression. So gamma square equals to j omega mu into sigma plus j omega epsilon. So from here, can I write it down in this manner? That it would be minus omega square mu epsilon, j into j will become minus 1. J into j will become minus 1. Omega square, omega into omega square, mu epsilon, and then plus j sigma, or you can say j omega mu sigma. Multiplied this and this, multiplied this and this, right? And gamma equals to alpha plus j beta I am assuming. So what is my alpha? Alpha is known as attenuation constant. Attenuation constant. We will come back to the derivation, but first we are studying about gamma, okay? And beta is already phase constant, that we already know. What was the unit for this? Radian per meter. What will be the unit for this? This is Napier per meter, okay? NP is Napier. Napier per meter. NP is Napier per meter, okay? It is known as Napier per meter. And 1 Napier is equals to 8.686 dB. This will be most probably given in the question paper. Like if they want the answer in dB, then they will give it in the question paper. But if it is not given, then you can remember it. 8.686, 8686, 8.686. Okay, and unit is Napier per meter. So if I do the square on both of the side, what I will get? Alpha square minus beta square plus 2j alpha beta. I hope you understand how did I do it. So alpha square plus j beta square plus 2 alpha j beta. So what will be j beta square minus beta square? Okay, so alpha square minus beta square plus 2 alpha j beta. So if I compare the real part and if I compare the imaginary part, so if I compare the real part, alpha square minus beta square is equals to what? Minus omega square mu epsilon, and 2 alpha beta is equals to omega mu sigma. If I solve both of them, I will get the value of alpha and beta. So here mathematical derivation we are not going to see how to solve both of them, but the expression that we are going to get now, that you need to remember. So write it down with me in your rough notebook, write it down with me. So alpha is equals to omega under root mu epsilon by 2, then bracket, then another under root 1 plus sigma by omega epsilon whole square minus 1. You feel like that's how we are going to remember it, but eventually you are going to remember it. Do not worry about it. Okay, slowly you will build up the habit of writing it again and again, and you will remember it. So let's write down beta. Beta will be written in the same manner: omega under root mu epsilon by 2, then again bracket, then again under root 1 plus sigma upon omega epsilon whole square plus 1. Here plus will come, here minus will come. That's it. I hope you are understanding where there is under root. Under root, whole under root is there, then mu epsilon by 2, then bracket, then under root is there on this quantity only. 1 plus sigma upon omega epsilon whole square. Okay, under root is there on this quantity only. And there is no under root on minus 1. This complete under root is certainly there. This complete under root is certainly there, but here there is no under root. Okay, so this is how we are going to write down the expression, and you write it down in your rough notebook at least 2 times. And if you write it down 2 times, you will be able to remember it. Omega mu epsilon by 2, then bracket, then under root 1 plus sigma upon omega epsilon whole square minus 1. Now this is a certain quantity, so we will discuss about this omega sigma upon omega epsilon. We will discuss about this. Okay, in this video only we will discuss about it. So later on you will be easily able to remember, because this is a certain quantity. This is known as loss tangent. So we are going to discuss about it, so you will be able to remember anyway. Okay, now this is the expression we are getting. This is the expression we are getting. Now we need to solve this expression. In the previous video, which expression did you get? This was the expression that you got. Here there was minus. Here there was minus. Then you took it on this side, then you did m square plus beta square, then you got the value of m is equals to plus minus j beta, then you got 3 expression. One E naught e to the power minus j beta z, then E naught dash e to the power plus j beta z, and the second one was linear combination of both of them. Then you pick only one option, that you said that I am assuming that my wave is traveling in positive z direction. So in the same manner I will do the same derivation. Here what will happen? Here you will get m square minus gamma square. So what will be the rule what will be the roots I will be getting? Plus minus gamma. So what will be the expression I will be getting? E naught e to the power minus gamma z, E naught e to the power plus gamma z, and other one would be the linear combination of both of them. So which one I will put? I will assume that my wave is traveling in positive z direction. So I will take the negative one. So from here I will get the expression E naught e to the power minus gamma z. Exactly did to the same derivation, only all the same assumptions are also there. So in the previous video we spent a lot of time on the derivation, so you can go and check out. So this is what you are getting, E naught e to the power minus gamma z, and your electric field component you are only taking in x direction. Okay, so this was our second assumption, that we are only considering EXX component. EYS component will also be there. EYS component will also be there, and EY and EZS component will certainly be 0. EYS component will be there. EYS component will be finite, but EZS component will be 0. Why is that so? Because our wave is traveling in z direction. So electric field cannot be in z direction. Right? I hope all these assumptions and all these derivation steps were clear to you. And once we get this expression, this is in phasor form. So now we need to go to the time domain representation. So for time domain representation, we can add e to the power j omega t, then take the real part and then take the imaginary part. Which expression I will entertain? Which expression I am going to entertain? Real one. The same analysis we did there exactly did to the same analysis we are doing here. So can I write down in this manner? What is this? E to the power minus alpha plus j beta z e to the power j omega t ax cap. Can this be equals to dl e to the power minus alpha z I am taking aside. Now this is a real quantity, e to the power minus alpha z. This is a complete real quantity. There is no j, right? E to the power jx, this is a complex exponential. E to the power x, this is a simple exponential. So this is real, this is imaginary. Are you getting this point? I should not say imaginary, this is complex. So there can be imaginary part of this, but there is no imaginary part of this. So e to the power minus alpha z, that is a complete real quantity. Then it would be e to the power j beta z and e to the power j omega t x cap, right? Now, minus sign is also there, e to the power minus j beta z. So this expression I have already written. So here only I can write down real part e naught e to the power minus alpha z, then e to the power j omega t minus beta z. Can I do in this manner? Just see this step, omega t minus beta z, right? Omega t minus beta z x cap. So what will be the real part of this? E naught e to the power minus alpha z cos omega t minus beta z. Okay, so this is the expression of electric field you are getting. What is the change? In the previous also there was the same expression, just new term introduced is this, e to the power minus alpha z. Is that clear to you? So here there will be attenuation as well. In the previous way, what was the graphical representation? In this way it was going, right? In this way it was going. So there was no attenuation in the amplitude, but now there will be attenuation. It will go like this. Okay, so everything we will see it. So just for the information I am telling that now there is a attenuation because of this term e to the power minus alpha z. What is the graph of e to the power minus alpha z? What did I assume? That my wave is traveling in positive z direction, right? Wave is traveling in positive z direction. So value of z is positive 1, 2, 3 and e to the power minus alpha z at z equals to 0, what you are going to get? 1. At z equals to infinity, what you are going to get? 0. So it will decay down like this. And other graph is cos. Other graph is cos. And if you multiply both of them, what you are going to get? This is what you are going to get. So in that manner your amplitude will decrease. Are you able to understand this point? This and this I am multiplying. So your amplitude will increase like this. Say yes or no, right? So this is your EZT expression you are getting. Now I need to get the expression of H field as well, magnetic field as well. So first I will get the expression of HS. First I will solve in phasor form only. So HS will be equals to del cross ES divided by, from here if I tell what is my HS, del cross ES divided by j omega mu and a negative sign. So del cross ES I need to calculate. So what I am going to get? This I will solve 0. AX component is 0. AY component is not 0. So AY component I need to write down. So what will be my AY component? So if you differentiate this with respect to Z, what you are going to get? Minus gamma E naught e to the power minus gamma Z. This you think you should be doing in your rough notebook on your own. This is simple mathematics, right? So you should be doing all this on your own. So del by Z, del Z E naught e to the power minus gamma Z. So minus gamma E naught e to the power minus gamma Z. This is what you are getting AY cap. This is your del cross ES. So this and this value I will equate. So minus gamma E naught e to the power minus gamma Z AY cap and minus j omega HS. So here I forgot to write AY cap. AY cap minus j omega mu HS. So what is the expression of HS you are getting? So this I am getting gamma E naught divided by j omega mu. Gamma E naught divided by j omega mu and e to the power minus gamma Z, right? And AY cap. You don't need to mug it up, like I also don't remember this expression. Just now we are going to define eta. So from here we can get to the time harmonic vector field, right? Just by applying j omega t. But before that, can you quickly define eta for me? Eta, if you remember, what was your eta? Eta was the ratio of their phasor representation, not of the amplitude. So now we need to take the ratio of their phasor representation. So I have the expression of HS, I have the expression of ES as well. So what is my ES? ES is E naught e to the power minus gamma z. Dropping the sign, I am not here, I am not putting the vector. So here you do not need to take the direction, only the magnitude of ES divided by magnitude of HS. So you do not need to take the direction, forget about the direction, only ES by HS. This is how eta is defined, ES by HS, forget about the direction. So ES by HS. So E naught e to the power minus gamma z, and here gamma E naught divided by j omega mu e to the power minus gamma. In this video we are just watching the mathematics, right? The first hour of EM wave was very important. There we actually understood how EM wave is traveling, but now we are just seeing the mathematics. So I know it might be boring for you, but this is required because you will not be able to solve the problem if you don't study all these things, right? So solving problems are also important. So e to the power minus gamma z, e to the power minus gamma z gets cancelled, E naught gets cancelled. So what will be the eta value you will be getting? So this j omega mu goes upward, j omega mu goes upward, and downward you are having gamma, right? So j omega mu, and these derivation as a gate aspirant you do not need to keep in mind, but just see it once so that you have the aptitude that how to get the derivation as well, right? What was the value of gamma? Gamma was j omega mu sigma plus j omega epsilon. From where I am getting it? Already we have solved it. This was your gamma now. Under root, here it is not written, here it is written. Under root j omega mu into sigma plus j omega epsilon. Just a second. Yeah, so let's solve it. ठंड बढ़ गई है ना, right? Winter has come, winter has arrived. So if you solve it, what you are gonna get? J omega mu upon under root j omega mu. So this is power 1 and this is under root. So what will be the final expression? Under root x. So upper side you are going to get j omega mu, and downward you are getting sigma plus j omega epsilon. So let's take this expression and then analyze it. So what we are getting? Under root j omega mu upon sigma plus j omega epsilon. You should remember it, okay? Another expression you are getting which you need to remember it. In the end we will write down the summary where we will write down all the expression, where we will write down all the formula as well. But for now you need to remember it, okay? Keep it in your mind. So what will be the okay? What I can do now? Can I take j omega epsilon outward, or just assume that in the numerator and denominator I am just dividing j omega epsilon. What I am doing in the numerator as well and in the denominator as well, I am dividing j omega epsilon. So what I am doing? This is whole big under root. Here was j omega mu. So here I am dividing j omega epsilon, and in the denominator as well I will divide j omega epsilon. So what I am gonna get? J omega epsilon divided by j omega epsilon will be 1 plus this is what you are going to get. So what will be the expression from here? J omega gets cancelled, and here what you are going to get? 1 minus, if this j goes upward, so what it will become? Minus j. 1 by j is equals to minus j, right? If this j goes upward, it will become minus j. So this is the expression of eta which you are getting, okay? So this is the other expression. So this you do not need to keep in mind, so let's not keep in the books, but just have the aptitude that this is the expression of eta, okay? Now eta will have a magnitude as well and a angle as well. In the previous video for free space and for lossless dielectric, what was your expression of eta? This was the expression of eta. For free space it was mu naught epsilon naught, so it was a constant value. Now this is a real quantity or it is a complex quantity? This is a real quantity, right? It is a real number. So there will be no angle. Angle will be introduced if it is complex. If it is a complex number, then only angle will be introduced. That will be tan inverse b by a. Since it is a real number, there will be no concept of angle. So that's why we did not write angle there, and we directly wrote that eta is equals to this thing. So if we had wrote down the magnitude, what would be the magnitude? This would be the magnitude. And what will be the angle? For the previous case, for the free space and lossless dielectric, what will be the angle? 0 degree, right? Because there is no B, tan inverse 0 by A. So tan inverse 0 and tan inverse 0 will be 0 degree only, right? So same goes here. Now here it is a complex quantity, right? So first we will write down the magnitude, then we will write down the angle. So let's write down the magnitude. So see it very carefully how we will write down the magnitude. Magnitude of this is same only. What about the magnitude of this? 1 minus j sigma upon omega epsilon. What will be the magnitude of this quantity? That would be 1 plus 1 square plus sigma square upon omega epsilon square under root. This will be the magnitude, right? Under root 1 square plus sigma square upon omega epsilon square. Omega epsilon square. Then there is another under root. Again I am saying, first is I need to take the magnitude of this. What will be the magnitude of this? A square plus B square. Then under root. Then there is another under root. So two under roots are there. Power 1 by 2, power 1 by 2. So it will be power 1 by 4. Is that clear to you? Power 1 by 2 into power 1 by 2. So that will be power 1 by 4. So can I write down the expression in this manner? That would be divided by 1 plus sigma upon omega epsilon whole square to the power 1 by 4. This is the magnitude of eta. What did I tell you? This quantity is special. This quantity is special, sigma upon omega epsilon. So we will discuss about it. So you will also be able to remember it. This expression we have already remember. Under root mu upon epsilon, right? Then extra term will be introduced, 1 plus sigma upon omega epsilon square. This 1 plus sigma upon omega epsilon square was there in the expression of alpha beta as well. 1 plus sigma upon omega epsilon square. Here there was under root, but now there will be two under roots. So power 1 by 4. Is that clear to you? Is this the way you will be able to remember it? Yes, you will be able to remember it. Okay. And also we will be discussing about sigma upon omega epsilon. So for after that expression will be more clear to you. So this is the value of eta. Try writing down the angle on your own. Try writing down the angle on your own. I have told you the concept a plus iota beta 1 upon under root a plus iota beta. How to write down the angle for these? I have told you this, right? So you can try writing down the angle for this quantity. So what is your answer? So let's try writing down the angle. That would be tan inverse. Forget about it. Let's not write down in this manner. I will directly write down the value of tan eta n. So do you remember this expression? How did we write down for this? Since there is 1 by, so minus sign. Since there is under root 1 by 2, then tan inverse b by a. Now in place of 1, I could have put any constant here, a upon under root a plus iota beta. So then also the angle will be same, no? Because this is a constant quantity. So any constant I can put. Here the constant is under root mu by epsilon, right? So what will be the angle? Angle will be under root is there, so minus 1 by 2. Why minus 1 by 2? Because it was a by something. So minus 1 by 2 tan inverse then y by x or b by a, tan inverse b by a. So what is your b? Minus sigma upon omega epsilon by a is 1. So that I am not writing. Is that clear to you? A upon something was there, right? A upon something was there. So ignore this a. If it was a upon something, so minus sign. If there was under root, so 1 by 2. Tan inverse b by a. So what is b? Minus sigma upon omega epsilon by a. A is 1. So this minus sign come outward because tan inverse x is equals tan inverse minus x is equals to minus tan inverse x, right? So this minus sign comes outward. So what you are going to get? If this minus sign comes outward, so eta n you are getting is 1 by 2 tan inverse sigma upon omega epsilon. What do you see? Again sigma upon omega epsilon. So this is something very special. So that we are going to see, that we are certainly going to see. But for now, these two expressions you are getting, and how you can represent eta now. So eta can be represented as magnitude e to the power j eta n. So do you know the value of magnitude? Yes, the value of magnitude is this. Value of magnitude is this. And do you know the value of eta n? Sorry, yeah, theta eta. This is the magnitude and this is your theta eta. What is that? 1 by tan inverse sigma upon omega epsilon. Is that clear to you? This is how we are going to write down the expression. Okay. So from this slide, under root j omega mu upon sigma plus j omega epsilon. Magnitude under root mu upon epsilon divided by 1 plus sigma upon omega square to the power 1 by 4, and then the angle. If you write it down 2 to 3 times in your rough notebook, and then you will be able to remember it, and in the end we will write down the summary as well, so it will be more clear to you, right? Now let's get the expression of HS. Right here we got the expression of HS. Now we need to get the time harmonic vector field. So in between we started discussing about eta. So now can I write down the expression of HS as E naught by eta? E naught by eta e to the power minus gamma z, because what was the expression? This was the expression, E naught j omega mu, and this gamma I can take downward. This gamma I can take downward, right? And what is this value? J omega mu upon gamma. J omega mu upon gamma. J omega mu upon gamma is eta. So E naught by eta e to the power minus gamma z. In that manner I can write down, yes. Now there is an interesting thing, that this eta has a magnitude as well, also it has some angle as well. Now this is having some angle. This eta has certainly some magnitude, but it has the angle as well now. In the previous case it was e to the power 0, e to the power j0, and e to the power j0 is 1 only. So we were not caring about that. But here it is having some angle. So if this eta goes upward, this is e to the power j theta n. If this goes upward, so what it will become? E to the power minus j theta n. Now I need to get the time domain representation. So what I am gonna do? I will add e to the power j omega t, right? And I will take the I will add e to the power j omega t, and then I will take the real part. So what I am gonna get? E naught divided by the magnitude of eta e to the power minus alpha z cos omega t minus beta z and minus eta n ay cap. So this is the expression of h y z t you are getting. Did you understand this expression? Here this is being divided by the magnitude of eta, but along with that it is having some angle as well. So if this goes upward, so it will come in the phase, no? This angle will come in the phase if this goes upward. So angle is coming in the phase as well. And that angle is now cos omega t minus beta z. Here omega t will be there. So omega t minus beta z minus theta neta. So theta will also come in action now. So what did you understand here? For free space and lossless dielectric, E and H were in the same phase. If this was your E, then this was your H. They were in the same phase. But now the phase is not same. If this is your E, then H might be somewhere starting from here. Like H will be lagging behind. H will be lagging behind by theta n. So let's see the diagram. It will be more clear to you. So this will be the diagram. If you see it more closely, let's take it here. The credit goes to EM Possible PDF. I got it from some PDF on internet. So from there I got this picture. So what do you see here? This is your E and this is your H. This is your H, this is your E. Where is the peak of E occurring? Here is the peak of E. Where is the peak of H? Here is the peak of H. Both are not in the same line. Like if you come here, if you take the projection of this point and if you go in the direction of H, then you are not getting the peak. In the previous case, if you go in the free space analysis, if you see here, what do you see? That if there is this peak, then take the projection and work here. Certainly there is a peak. So E and H were having the peak at the same time. But now the things have changed. They are not having the peak at the same time. That means there is a difference in phase. Right? Let's come back to our point. Here we are. So there is a difference in phase. And what is that difference? That E is leading by theta neta. E is leading H by phase theta eta, right? So there is a phase difference. So if I say a statement that in lossy dielectric, E leads H by the angle theta eta. Is that clear to you? I should not say angle, I should say phase. So E leads H by the phase theta eta. Is that clear to you? Theta eta. Okay. You can call it theta n. Actually it should be called theta eta, but somewhere when solving the problems I will call it theta n sometimes. Okay. So don't get confused what is theta n. It is theta eta only. But theta eta seems like a funny name. So sometimes I will call it theta n as well. So there is a phase difference. So this is the difference now. Also, what is the other difference? The magnitude is getting decreased. Magnitude is getting decreased. Why magnitude is getting decreased? Because of e to the power minus alpha z. Because of this guy, the magnitude is getting decreased and there is a phase difference as well. So whenever your EM wave is traveling in lossy dielectric medium, then magnitude will also decrease. Along with that, there will be a phase difference between E and H. Is that clear to you? Yes. So let's write down the key properties. Both are same. Transfer electromagnetic wave and direction of propagation is perpendicular to the direction of electric field and the direction of magnetic field. AP is equals to AE cross AH. So this we have already seen, which was common for everyone. Now the expression of E and H. So this was the expression of E. This was the expression of H, where H naught was equals to H naught is equals to E naught by eta. No, E naught by eta magnitude. The angle is going here. E naught by eta magnitude, and the whatever the angle of eta is, that has been fed here. And what was the angle of eta? That was 1 by 2 tan inverse sigma by omega epsilon. Is that clear? And what was the magnitude of eta? What was the magnitude? Under root mu upon epsilon, then 1 plus sigma upon omega epsilon, 1 plus sigma upon omega epsilon whole square, 1 plus sigma upon omega epsilon square to the power 1 by 4. Not under root, to the power 1 by 4. So under root mu upon epsilon upon 1 plus sigma upon omega epsilon whole square to the power 1 by 4. Do not panic. Like you will be thinking that, sir, there is very less time left for gate examination. How we will be able to remember this formula? You will be able to remember. Just wait for the next lecture. Till the end of the next lecture, you will say that we remember every formula, sir. Because we will solve the problems. The best way to remember any formula is to solve the problems. So with respect to every single formula, we will solve the problems, and when you solve those problems, you will remember the formula on its own. Just believe me, okay? So there are certain formula which you need to keep in mind. So this is the other one as well. And once we will write down the summary, so at one page only all the formula will be there, so you can see it and write it down again and again in your rough notebook. So E and H is not having the same phase, and H is lagging by theta eta, or you can say E is leading by theta eta. H lags by theta eta or E leads by theta eta. Is that clear? Okay. This was the expression of alpha and beta. These two were the expression of alpha and beta. So again write it down in your rough notebook. Omega under root mu epsilon by 2, then bracket, then under root 1 plus sigma upon omega epsilon whole square minus 1 plus 1. For alpha minus 1, beta plus 1. Okay. How will you remember? That here minus 1 will be there and here plus 1 will be there. So what is your alpha? Alpha is attenuation constant, right? Alpha is attenuation. So if there is some attenuation, if something is getting decreased, then minus has to be there. That's it. This is how you can remember. For longer run, you are able to remember it. Like in the end, you will be able to remember it for a longer time. But for now, if you want to keep in mind that, sir, how plus and minus. So attenuation, alpha is attenuation. If something is getting attenuated, so minus sign will be there. This is how you can remember. And what will be your time period? Time period will simply be 2 pi by omega, right? Time period will be 2 pi by omega only. What will be your phase velocity? Vp is equals to omega by beta, right? But beta value is this. Vp is equals to omega by beta, but now beta value has changed. So beta is not equals to here. Beta is not equals to omega mu epsilon. Now this is the expression of beta. So beta has changed now, okay? So beta expression has been already written, so I am not writing here. So Vp is equals to omega by beta. This will always work. T equals to 2 pi by omega always works. But expression of beta changing here, okay? Graphical representation we have already seen. What about intrinsic impedance? So again we are writing. So one expression we got, which was j omega mu upon sigma plus j omega epsilon, and then there was under root. So this was the expression, and if we take the magnitude of that, what we were getting? Under root. Again and again I am writing down all these formulas so that you remember it for a longer time. So your job is to write down these formulas with me. sigma upon omega epsilon square to the power 1 by 4. And what is the angle? 1 by 2 tan inverse sigma upon omega epsilon. So this was the angle and this was the magnitude. So from here, what do you write? Magnitude e to the power j theta. Okay. Now there will be a term introduced, Loss tangent. So let's understand about it. What is a Loss tangent? Loss tangent is simply the ratio of conduction current magnitude divided by displacement current magnitude. That's it. So if I talk about lossless dielectric, so in lossless dielectric sigma was 0. If sigma was 0, then what was your conduction current? 0. So here total current density was equals to displacement current density only. In lossless dielectric, there will be no conduction current because there is conductivity. Is equals to 0. There is no conductivity. So all current will be equals to displacement current. So what will be your loss tangent? Loss tangent is shown by tan theta. Loss tangent. So it is shown by tan theta. There is no conductivity. So 0 by JD. So this will be your loss tangent. So your loss tangent is 0. There will be two terms. Tan theta is known as loss tangent. Okay. And theta is known as loss angle. Okay. Two terms are there. Tan theta is known as loss tangent and theta is known as loss angle. So what is the loss angle here? 0 degree. Because if tan theta is 0, then loss angle will be 0 degree. Now what about this? Lossy dielectric. So sigma is finite here. I am not saying it is infinity. It is some finite value, right? It is some finite value. Sigma is some finite value. So this will also come in action. This will also come in action. Can I write down del by del t as j omega epsilon? When I can write down? When I am dealing in phasor representation. So when I am dealing in phasor representation, this is what I can write. Now I just need to take the ratio. This is my loss tangent. So if I take the ratio of the magnitude, so sigma epsilon s, sorry, sigma es, and what will be the magnitude of this? J will be not there. Like what is the magnitude of j beta? What is the magnitude of jb? Only b, no? So same goes here. What is the magnitude of j omega epsilon es? That will be omega epsilon es only. Okay, so what you are getting? Sigma upon omega epsilon. For good conductor, this is your sigma. Sigma is towards infinity. So that we will discuss in the next particular lecture. In this lecture only, in the second half of this lecture, we are going to discuss about conductor. So between the lossy dielectric and conductor there is only one difference, that is here sigma is very high. That's it. This is the only difference. So within 10 to 15 minutes we are going to see about good conductor as well. So in this half only we are going to see. First let's discuss about lossy dielectric, because we are studying lossy dielectric as of now. So for lossy dielectric, tan theta is equals to sigma upon omega epsilon. So let's discuss about it. So tan theta is equals to sigma upon omega epsilon. The same formula will be there for good conductor as well. But what will be the difference in conductor? The difference in the conductor will be that this value will be very high. So if sigma upon omega epsilon is very very high, then it is known as good conductor. If sigma upon omega epsilon is not very high, or I can say decent value, if it is a decent value, then it is known as lossy dielectric. And one more condition I will write down. If tan theta is equals to 0 degree, if tan theta is 0 degree, that means it is lossless dielectric, right? Lossless dielectric, not 0 degree. I should write tan theta is equals to 0 because angle is 0 degree. If tan theta is equals to 0, that means sigma is equals to 0. If tan theta is equals to 0, that means sigma is equals to 0. And if sigma is equals to 0, that means it is lossless dielectric, right? Or free space. Now sigma upon omega epsilon is very very less than 1. It is not equals to 0. It is not equals to 0. It is very very less than 1. That means it is towards 0. So certainly there is a loss. There is a sigma. If there is sigma, that means there will be a loss. If there is sigma, that means there will be loss. So certainly there is a loss, but the loss is pretty low. So it is known as low loss dielectric. Dielectric. low loss dielectric. Okay, the loss is pretty low. This value is very less than 1. So certainly there is a loss, but the loss is very finite. So based on the value of sigma upon omega epsilon, what you are getting 4 conditions. If it is very high, it is a good conductor. If it is decent value means like some under root 3, under root 4, or which is equals to 2, under root 7, under root 9, which is equals to 3, or 10, 11, these are also different value. But if you are getting somewhat around 3000, so that will be very high. Why it will be very high? Very high with respect to 1. So it is very high. So if it is very high, then it would be good conductor. If it is a decent value, then it is lossy dielectric. And if it is very less than 1, let's just say if you are getting 0.001 sigma upon omega epsilon, you are getting 0.001. So that will be your low loss dielectric. Low loss dielectric. Okay, this term might not be used in your questions. Like you will not find this term in your questions, but just a term is given, low loss. The loss is there, but the loss is pretty low. And if it is 0, if sigma is 0, then certainly it is free space or lossless dielectric. Is that clear? Now let's see one more interesting thing. So what is the value of theta you are getting? Tan inverse sigma upon omega epsilon. And for a general medium, what was your eta n? That was 1 by 2 tan inverse omega epsilon. This was your eta n. Theta n you can say, or eta neta or theta n, whatever you can say. So this was your theta n, theta neta. So what was your theta neta? 1 by 2 tan inverse sigma upon omega epsilon, theta neta. Okay. So what do you get from here? That 2 theta neta, if you take this 2 here, then what it will be equals to? Theta. This was your Loss tangent. And not Loss tangent, Loss angle. And this was your intrinsic angle. Intrinsic impedance angle. Intrinsic impedance angle. So theta is equals to 2 theta neta, or this is what I am getting, or I can write theta is equals to 2 theta neta. So this also you can keep in mind. Okay. So another formula which we need to keep in mind. This formula, then this formula, these two formulas. Vp is equals to omega by beta and T is equals to 2 pi by omega. This you already know. H naught you know, theta neta you already know, and magnitude of theta you need to keep in mind. So these things you need to remember. Okay. We will write down all these at one point once we study the conductor. After that we will write down all these points at all this formula at one point only. So eventually you are going to remember it. Do not worry about it. So theta is equals to 2 theta neta. How will you remember? Like people will get confused that sir this will be the expression, or sir this will be the expression. So whenever there is subscript, then there is another number. Like theta will come alone. If there is some subscript, then number will be there. Like people will be getting confused between these two. So how do I actually remember? If there is subscript, then I will put 2. That's it. So theta is equals to 2 theta n. This is how I remember. You can also remember in the same manner. So this is everything about our lossy dielectric. So there is some loss which is finite. Another term we introduce here which is low loss dielectric. Okay. Now let's see a very simple point which is complex relative permittivity. So I told you I will talk about it when we study EM waves. So permittivity could be complex as well, like epsilon is equals to epsilon naught epsilon r. This is a constant value. So what will be the complex term? This will be the complex term. So this is given as epsilon r complex. I am writing epsilon r dash minus j epsilon r double dash. So from here important point is what is the ratio of epsilon r dash divided by epsilon r double dash divided by epsilon r dash. Basically the ratio of imaginary part to the real part. What is that? That is equals to Loss tangent. Okay, this is equals to your Loss tangent. Can you keep in mind? Yes. So this ratio is equals to Loss tangent. If there is some question on this in 1 mark or in 2 mark, very rarely this will be asked. Till now they did not ask it, but if they ask it in the examination, then you can solve, right? The use of complex permittivity has not been introduced. Like there was a question in gate examination where they gave the epsilon r equals to 1 minus 2j, something like that, and mu r also equals to 1 minus 2j. But this formula was not used there. Without even using this formula, you could have solved this question. So this complex permittivity can be introduced in your examination, but there is very rare chance that they will ask any question on that. Okay, but if they ask, you can remember one basic thing, which is that the ratio of imaginary part to the real part will be sigma upon omega epsilon, and that will be equal to your loss tangent. Is that clear to you? Sometimes if they ask some question, then you can keep in mind. Okay, so now we are going to study about free space, sorry, not free space, we are going to study about conductor. So for conductor, sigma will be very high. So that we are going to see in the second half of this video. So you can pause the video, take a break, drink some water, and then come back and start studying about good conductor. Okay, so sigma will be very high there. Thank you very much. Let's meet in the second half of this video. Yeah, so let's analyze EM wave in a good conductor. Okay, so now sigma will be very high here. Sigma will be very high. Certainly we will consider charge free region. So rho v is equals to 0. Epsilon will be equals to epsilon naught epsilon r, and mu will be equals to mu naught mu r. And instead of writing sigma to be very high, we should write sigma upon omega epsilon is very greater than 1. Okay. The condition for good conductor is this. Like this is more relevant. Sigma very high. Okay, sigma if very high, then certainly it is more. Certainly it is good conductor. But if sigma upon omega epsilon is very greater than 1, then also you will say that it is a good conductor. So this is more relevant. So you will remember this thing, that sigma upon omega epsilon is very greater than 1, rather than remembering that sigma should be very high. This is the thing that you need to remember for a good conductor. Okay, so this is what I am highlighting, that sigma upon omega epsilon should be very greater than 1. Okay, now this is a conducting medium. This is what we are assuming. This is a conducting medium, conductor. So it will have some sigma, and if there is some sigma, that means there will be some loss. And if there is some loss, so let's just say this was air. This was air. So from air to conductor we are going. From air to conductor. So in the air, your EM wave was not losing its amplitude. The amplitude was always same. But once it goes into conductor, it will start losing its amplitude. It will start losing its amplitude. Okay. So in the end, there will be very less amplitude left, right? So almost complete EM wave will be eradicated. Inside the conductor, almost complete EM wave will be eradicated. Like it will lose all its energy. Energy means it was having some amplitude. If there is some amplitude, that means it is having some power. So this EM wave is going to lose all its power inside the conductor. Is that clear to you? Okay. And okay, we will write down electric field and magnetic field expression later on. So as of now, what did you understand? Conductor sigma should be very high, or better you should say sigma upon omega epsilon should be very high. Now it is just a special case of dielectric. Like we derived the expressions of dielectric medium. Which dielectric medium? Lossy dielectric medium, considering sigma to be finite, right? We considered sigma to be finite and got some expressions. Do you remember that? In just 10 minutes before we did this thing. So there sigma was finite. Now what we need to put, we just need to put sigma to be very high. We just need to put sigma upon omega epsilon to be very greater than 1. So from this condition, what I can get? From this condition, what I can get? That your sigma is very greater than omega epsilon. So better than saying that sigma is very high, I should say sigma is very greater than omega epsilon. So this is also one of the conditions. So these conditions we will use and we will derive the new formula. So all the formulas will be same, just some modification we are going to do and we are going to derive the formula. So a conductor is just a special case of dielectric where sigma is very high, or I should say where sigma is very greater than omega epsilon. Better should be written that sigma is very greater than omega epsilon, or you can write down that sigma upon omega epsilon is very greater than 1. So what was your propagation constant? General propagation constant for a lossy medium. For any lossy medium, what was your propagation constant? Do you remember it? Right now you might not be able to remember, but slowly you are going to remember it. J omega mu upon sigma omega, J omega mu into sigma plus J omega epsilon. Now sigma is very greater than omega epsilon. Sigma is very greater than omega epsilon. So can I take omega epsilon nearly equals to 0? Can I take this quantity nearly equals to 0? Because sigma is, let's just say, some 5000 and this omega epsilon will be some 0.1. So can I assume it nearly equals to 0? Yes, it is nearly equals to 0 with respect to sigma. So what is the value of gamma you are getting? So gamma you are getting is j omega mu sigma. Okay, so you don't need to mug it up. Just in the examination you will remember this thing and there you can derive it. What about alpha? What was your alpha? So somewhat downward I will write. So my alpha was omega under root, general expression I am writing for a general lossy medium. So it was omega under root mu epsilon by 2, then a bracket, then under root 1 plus sigma upon omega epsilon whole square and then minus 1. This was the expression, right? Now this value is very greater than 1. Sigma upon omega epsilon is very greater than 1. So if it is very greater than 1, can I ignore this one? 1 plus 1000 or 10,000 will be nearly equal to 10,000 only. No? It will be 10,001. So it is nearly equal to 10,000 only. So same thing I am doing. I am ignoring this one, right? So what I am gonna get if I ignore this one? What I am gonna get? Sigma upon omega epsilon whole square and then under root. So what will be the answer? This and this will get cancelled. What you are gonna get? Sigma upon omega epsilon. Sigma upon omega epsilon minus 1. In the bracket what is there? Basically this expression has been reduced to sigma upon omega epsilon. Now sigma upon omega epsilon minus 1. From 10,000 you are subtracting minus 1. What you are going to get? Nearly 10,000 only or 9,999. So it is nearly 10,000 only. It is nearly 10,000 only. So again this one can also be ignored. So this one also I can ignore. So from this particular bracket, what you are getting? You are getting sigma upon omega epsilon directly. This one was ignored, under root and square was getting cancelled, and then this one was also ignored. So sigma upon omega epsilon I am getting. So what I am getting? Omega mu epsilon by 2 into sigma upon omega epsilon. So epsilon got cancelled. So what you are getting here? This is under root omega, this is complete omega. So what you are getting? Omega mu sigma by 2. Omega mu sigma by 2. Is that clear to you? If you are able to remember it, then it is pretty good. If you are not able to remember, then also it is fine. Because in the examination, you will be able to derive it very quickly by this expression. So if you are able to remember, then it is good. If you are not able to remember, then don't push yourself. Okay? Because we are going to solve a lot of problems. Eventually, you are going to keep in mind. So what you are getting? This is what you are getting. This is the expression of alpha. Otherwise, you can derive in the examination as well. Okay? So under root 2 pi f mu sigma, right? This can be written as omega is equal to 2 pi f into mu sigma divided by 2. So 2 and 2 get cancelled. Another formula you are getting pi f mu sigma. So this is also another expression which if you want to remember, then you can remember, otherwise you can drop it as well. Now what do you think, what will be the expression of beta? Beta will be equal to alpha. Why is that so? Let's check that out. So beta is equal to omega under root mu epsilon by 2 under root 1 plus sigma upon omega epsilon whole square plus 1. This was the expression of your beta. Now what this can be replaced to? Sigma upon omega epsilon only. Say yes or no? Because 1 plus 1 is very small. Sigma upon omega epsilon is very high. So 1 can be ignored. Then plus 1 is again there. So this one can also be ignored. So this complete term can be reduced to sigma upon omega epsilon. So the same expression you are going to get. Basically here 1 has no importance. Why 1 has no importance? Because 1 is very small with respect to sigma upon omega epsilon. Here we have written that sigma upon omega epsilon is very high. So 1 has no importance. So from here what did you get to know? That expression of alpha and beta are same. So what I am writing? Alpha is equal to beta. So whatever that I have kept in box, that you can try to remember. This thing you need to remember, that alpha is equal to beta. Alpha is equal to beta. This you need to remember. This if you want to remember, then it is pretty good. If you are not able to remember, then also it is fine. You can derive in the examination. But alpha equals to beta, this you can remember. This gamma expression I am not asking you to remember. This gamma expression I am not asking you to remember. If it is useful, then you can derive in the examination. Is that clear to you? So only which thing you can remember is that alpha is equal to beta. If this is also there, then that is also pretty good. So alpha, beta we have seen, gamma we have seen. Let's see intrinsic impedance. So tell me one thing. Here sigma is very greater than omega naught. Sorry, omega epsilon. Sigma is very greater than omega epsilon. That means this guy is very small with respect to sigma. So I can keep this guy nearly equals to 0. Omega epsilon is nearly equals to 0. So what you are getting as neta, j omega mu divided by sigma. So how will you write it down? In the examination you will write down that sir, neta general expression is j omega mu upon sigma plus j omega epsilon. So j omega epsilon will be 0 only. So this is the expression I am getting, right? Now this is the expression of eta, which you will be able to derive very quickly. What is the magnitude of this? What is the magnitude of this? Magnitude of this is under root omega mu by eta, right? Just the magnitude I need to take. So j part will not come, so this will be the magnitude. What will be the angle? So under root omega mu by under root omega mu by sigma. Under root omega mu by sigma, this is the real part. What is the imaginary part? Under root j. What is the angle of under root j? What I need to write down now? This is what I need to write down. So I need to write down the angle of under root j. How will I write down? Since there is under root, so 1 by 2. Tan inverse imaginary part, that what I used to do, b by a. That means imaginary part which is 1. There is j. So j into 1 is j only. So imaginary part which is 1. What is the real part here? There is no real part. So 0. So 1 by 2 tan inverse infinity. 1 by 0 is infinity. Tan inverse infinity is 90 degree. So 90 by 2, 45. Did you understand? What is the angle of under root j? Like people usually remember it because under root j can be written as e to the power j pi by 2. Sorry, j can be written as e to the power j pi by 2 and then you are taking half power. So e to the power j pi by 2 is your j. E to the power j pi by 2 is your j, right? And then you are taking 1 by 2 as well. So e to the power j pi by 4. So what is the angle? 45 degree. Or this way also you can see it. So angle is 45 degree. Very basic mathematics. Very basic mathematics. Very basic. So angle is 45 degree. Is that clear? So what will be the expression of Ex? E naught e to the power minus alpha z cos omega t minus beta z Ax cap. This is what I am assuming. Basically assuming that my wave is traveling in positive z direction and only Exs component is present. So this is the expression we get. Same goes for Hyt as well. E naught by magnitude of eta e to the power minus alpha z cos omega t minus beta z, and whatever the angle here is, that will go upward here. So what is that angle? That angle is 45 degree Ay cap, because here the angle is fixed. There would be some phase difference between E and H. Now here the phase difference is fixed, which is 45 degree. Is that clear to you? So in a perfect conductor or in a very good conductor, you will see that E will lead H by 45 degree. Is that clear? So this we have seen now. What else? Loss tangent. So loss tangent tan theta is equal to sigma by omega epsilon. Now you will say that sir, it is sigma is very large, so we can put it equals to infinity, and then theta equals to 90 degree we are getting. Okay, it is fine. It will be nearly equals to 90 degree only, but let's not keep it here. In some problems you will see that it might not be equals to 90 degree. Okay, nearly around 90 degree it would be, like sigma is very greater than omega epsilon, right? So nearly it would be equals to infinity. If tan theta is equals to infinity, then what is the angle? 90 degree. Yeah, it is fine, but let's not keep it. So just I am writing it, tan theta is equals to sigma upon omega epsilon. So what will be your theta? Theta will be equals to tan inverse sigma upon omega epsilon. So now this is your theta, which is like loss angle, it is known as. So this we have already seen in the previous video. Now there is new term which is known as skin depth. So what did I tell you? When EM wave travels in the conducting medium, so its amplitude decreases. If it was E naught, then slowly it will decrease. From H naught also it can decrease. I am only showing the electric field. I am only showing the electric wave. So from E naught it is starting to decrease. Now if at some distance, it will be E naught by E as well. Once it is traveling in this medium, at some distance it will be E naught by E as well. Initially it started from E naught. What was the expression? E naught e to the power minus alpha z. Only about the amplitude I am talking. The complete expression was this. What was the amplitude? This was the amplitude. So I am talking about E naught e to the power minus alpha z. E naught e to the power minus alpha z. So at some distance it will be E naught by E as well. So that distance is known as skin depth. Okay, so this is what I have written. So let's not make this diagram messy. Yeah, so it is the measure of the depth to which an EM wave can penetrate through a medium, or you can say through a conductor. And what is the definition of skin depth? So it is a distance traveled by EM wave inside the conductor through which its amplitude decreases by 1 by E of the maximum amplitude. So what was the maximum amplitude we are assuming? E naught. So now we need to get the amplitude equals to E naught by E. So from E naught to E naught by E we are going. So what will be this distance called? This distance is known as eta, or you can say skin depth. Okay, skin depth. By this sign I'm gonna show it. So what will be the expression of skin depth? So what I am showing here, this is z less than 0. So this is some air, you can say, or free dielectric, you can, or free space, you can say, or anything you can say, air, free space, or lossless dielectric, whatever you want to call it. Okay, whatever you want to call it, you can call it. Once it is going into the inductor, for z less than 0, it was lossless medium. Once it is going into the conductor, then it is lossy medium. If it is lossy medium, so it is losing its amplitude. So how it is losing its amplitude? From E naught to E naught by E. So at z equals to eta, like this is also eta and this is also eta only. So this we can call neta. Okay, basically z equals to this sign. It is known as eta only actually. Z equals to, at this sign, what will be the amplitude? The amplitude of E field at z equals to this sign, your amplitude will be reduced to E naught by E. Or can I write down E naught to the power minus 1? So if you compare, what you are getting, alpha eta is equals to 1. So what is your skin depth? Skin depth is simply the reciprocal of your attenuation constant. Reciprocal of attenuation constant. What will be its unit? What do you think? What will be its unit? Nepper per meter. Sorry, meter per nepper. Like unit of alpha was nepper per meter. So what do you think? It will be meter per nepper? No. The unit will be meter only, no? Unit will be meter. Right? Unit will be meter because it is a depth. How much distance has been covered? So unit will be meter here. Okay? Unit is meter. So what is your skin depth? The distance it is traveling to reach a distance, to reach an amplitude of E naught by E. Starting from E naught to reach the amplitude of E naught by E. That is known as skin depth. So what is the formula of skin depth? It is just the reciprocal of your attenuation constant. So if they are asking you the skin depth, then what you are going to calculate? You are just going to calculate the attenuation constant and then take the reciprocal of that. So these are the things which we need to study about conductor. So let's start again revising it. So sigma upon omega epsilon very greater than 1. So sigma is very greater than omega epsilon. So these were the formulas we have developed. So from here, if you want to remember this formula, alpha is equals to omega mu epsilon by, omega mu sigma by 2. So this you can keep in mind, and alpha is equals to beta. This you need to keep in mind as well. And eta expression very easily you will be able to write down under root j omega mu by sigma, and then omega epsilon will be kept as 0. So this is the magnitude and angle is fixed. So E is leading h by 45 degree. And Loss tangent is the same. Skin depth is just the reciprocal of your attenuation constant. That's it. Okay, so let's write down the summary of everything that we have studied. But before that, let's solve a numerical. So this is the question given. Intrinsic impedance of a medium is given. Okay, so eta is given. So looking at this thing, what can you conclude? That it cannot be free space and neither it can be lossless dielectric. Why is that so? Why is that so? Dielectric. Because for both of the cases, theta eta is equals to 0 degree. So it cannot be both of them. So what I am going to write? It is not possible. So what it can be? There are two options. Lossy dielectric. Actually, there are three options. Lossy dielectric or low loss dielectric. That loss is low. Low loss dielectric, or it can be conductor. If it is a conductor, then eta in is equals to 45 degree, right? Theta neta is equals to 45 degree. So this is also not possible. Conductor is also not possible. If it is low loss, then it would be nearly equals to 0. or I can say tending towards 0 degree, or I would write very, very low, very low. Because what will be the intrinsic impedance, sorry, what is this angle? This theta neta which we are talking about, that is 1 by 2 tan inverse sigma upon omega epsilon. So if sigma is very low, here sigma is not 0, but sigma is very low. So this angle will also be tending towards 0 only. So I am writing theta neta is very low. Here theta neta is 30 degree. So yeah, this is the medium. So it is lossy dielectric, or you can say it is a general medium only. Lossy dielectric means general medium. Whatever the formula we have derived, considering sigma is equals to finite. So it is a general medium. So angle is given 30 degree. So whenever you solve an equation, just try to get this value. This is very important. You need to get the value of sigma upon omega epsilon. If you have the value of sigma upon omega epsilon, you can solve the problems very easily. So always our first task would be to get this value sigma upon omega epsilon. So 30 degree into 2 tan inverse sigma upon omega epsilon. So tan 60, what is the value of tan 60? Under root 3. So sigma upon omega epsilon is equals to under root 3. This is one of the things which we are getting. What we need to find? We need to find the value of alpha. So do we have the value of omega? No, we don't have the value of omega. We have the value of beta, right? We have the value of beta. So what we have? We have the value of beta. Beta is equals to 1 by 2. Beta is equals to sin omega t minus beta x. So beta is equals to 1 by 2. So if we have the value of beta, do you remember the formula of beta? Yes, omega under root mu epsilon by 2 and then under root 1 plus sigma upon omega epsilon square plus 1, right? Now, okay, now what do I need to find? I need to find the value of alpha. So if you have the value of beta and you need to find the value of alpha, do you have this value mu r epsilon r? Like mu is equals to mu naught mu r, right? And epsilon is equals to epsilon naught epsilon r. This value we remember. This value we remember. But do we have the value of mu r epsilon r? No, we don't have the value of mu r and epsilon r, right? So basically this formula is of no use now, because if you want to get any value from this formula, then you need to have this mu r epsilon r values, which you are not having. So a very important tool I am gonna tell here, that is ratio of alpha and beta. So alpha by beta, if I need to calculate, this will be used in a lot of problem. So let's write down the formula of alpha, that is omega under root mu epsilon by 2 under root 1 plus omega square. This under root should be kept clearly. Okay, so this is the value of alpha, and what will be the expression of beta? For writing the expression of beta, under root 1 plus sigma upon omega epsilon square plus 1. Okay, now omega and omega get cancelled. Tell me one thing, under root 5 into 2 upon under root 7 into 2, what is the value of that? Under root 5 by 7. Do you agree to this point? Do you cancel those under roots? No, right? when I used to be a student, I used to cancel this under root in this expression. Here you are not going to cancel, like it is very clear, but sometimes I have seen student cancelling this. Okay, so don't cancel this thing. Other thing, 2 and 2 can get cancelled, right? 2 and 2 get cancelled. So this and this can get cancelled. So what is the expression you are getting? Now tell me one thing, can I put sigma upon omega epsilon equals to tan theta, right? Because this is our Loss tangent. So sigma upon omega epsilon I can keep as tan theta. So alpha by beta. So under root 1 plus tan square theta. Under root 1 plus tan square, and big under root is also there. Like basically this under root is certainly there. Then another one under root is there. That is under root 1 plus sigma upon omega epsilon square. So let's forget this thing. In this expression, what we have? We have the value of 1 plus sigma upon omega epsilon. We have the value of sigma upon omega epsilon, that is under root 3. So under root 3 square, that will be 3 minus 1 divided by under root, divided by this under root, then another under root 1 plus sigma upon omega epsilon. Sigma upon omega epsilon is under root 3. So under root 3 square is 3 plus 1. So now this will be equals to under root 3 plus 1 is 4, under root 4 is 2, 2 minus 1 divided by, you need to do this calculation with good amount of patience. What I am doing, under root is there, this is getting cancelled, this big under root is also there. So do not forget this big under root. This big under root is also there. Inside there is under root 1 plus this value, which is equals to root 3. So this is 3, 3 minus 1 upon under root 1 plus 3 plus 1. So what you are getting? 2 minus 1, and here you are getting 2 plus 1. So what is the ratio of alpha by beta you are getting? 1 by under root 3. So from here, can you tell me the value of alpha? Yes, alpha will be, alpha by beta is 1 by under root 3. So alpha will be equals to beta into 1 by root 3. So beta is 1 by 2. So 1 by 2 root 3. That will be Nepper per meter. And beta is equals to 1 by 2 radian per meter. But let's not write down the value. So this is the value of alpha. So this is a very important tool. Okay. If you are having the value of sigma upon omega epsilon, then you will use this formula. It will be very helpful for you. Just the ratio, right? So alpha value we have got. Electric field expression we need to write. Okay, this is the expression of a magnetic field. So if you need to write down the expression of electric field, what else you will be needing? Neta. Neta we already have. Magnitude of neta is 200. Basically from here, can you get me the magnitude of eta? That will be 200. What was your H naught? H naught was E naught by eta magnitude. It was E naught by eta magnitude. So what will be your E naught? Eta H naught. This will be your E naught. So just multiply this magnitude. Thus just multiply this magnitude with 200. So this is the value of E naught. Are you getting this point? I have got the value of E naught. How I have got the value of E naught? Eta into H naught. Eta into H naught, but eta magnitude. Eta into H naught. So I am writing down the expression of electric field here. So 200 into 10 cos omega value I don't need, omega t minus beta z. Okay, let's write down in the next page only, because I need to write down the expression of alpha as well. So I will add a page. Just one sec. Yeah, so I need to write down the expression of electric field. So how will I write down? So 10 200 into 10. Why 200? Because you know that E naught is equals to eta H naught. Right? So 200 into 10 e to the power minus alpha z cos omega t minus beta z. What will be your beta? 1 by 2. Not z. Actually here wave is propagating in positive x direction. So minus 1 by 2x plus 30 degree. Why is that so? Because E will lead H by 30 degree. H will always lag behind by 30 degree. So E will lead H by 30 degree. So here if the phase is 0, then plus 30 degree I am going to do. Now I need to write down the direction here. This direction I need to write down. So where my wave is propagating, one formula I know. This formula I already know. Where my wave is propagating? My wave is propagating in x direction. This is the direction of wave. Omega t minus beta z, you can see opposite sign, that means plus x. Electric field direction I need to find. So let's keep it blank. And what is this direction? What is the direction of magnetic field? Ay cap. So direction of magnetic field is Ay cap. So what will be this direction? What do you think? X, Y, Z. So x, what I need? I need the final answer x. So y cross z gives me x, but y is here. So if I put z cross y, so z cross y will give me minus x. So another minus sign I need to put. So what I am gonna get? Minus az cap. So these things we have solved again and again. I think you should be habitual with that, and you should be able to write down this on your own. This is how I am gonna write down ax, ay. Then what do I know? That I need something cross y. So this has to be in z only. So z cross y I need. Z cross Y. Z cross Y is giving me minus X, but I actually need plus X. So negative sign I'm going to put, so negative sign will come here. So this is the complete expression of electric field. So this is how you are going to solve a general problem. Is that clear to you? Oh, let's keep it here. Okay. Yeah. So these are the things. Also I can write down E leads H by 30 degree. So in the next video we are going to see the assignment only. So there we are going to solve a lot of problems. So you will be more comfortable with the problem. So in the next video everything will be clear. Okay. That will be based on assignment itself. Now let's see the summary. So for a general medium I am going to write down all the expression. For one general medium I am going to write down all the expression. Do not skip this summary, it is very important. And one more kind of medium I am going to introduce, that is low loss medium I am going to introduce. So that also is important for you. So transfer electron TEM wave, these are AP is equals to AE cross AH, which is true for everyone. This is the expression of your electric field. This is the expression of your magnetic field, where H naught is equals to E naught by magnitude of eta, and H will lag by theta n or eta degree from electric field. Basically electric field will lead H by theta eta. So this angle will also come, right? I am assuming my wave is traveling in positive Z direction. Wave is traveling in positive Z direction and electric field is in plus X. This is what I am assuming. Is that clear to you? Now let's write down the expression of eta. So what was the expression of eta? General expression, that was j omega mu upon sigma plus j omega epsilon. This was the expression of eta. Now you should start remembering these formulas. When you calculated the magnitude, what came? This was the magnitude which was coming, 1 plus sigma upon omega epsilon whole square to the power 1 by 4. Like somewhere you would see that sigma upon omega epsilon can be kept as tan theta. So 1 plus tan square theta will be sec square theta, and sec square theta you can take 1 by power 4. So that will be under root sec theta. So this is how also formula can be written, and that is also a good way. But I am habitual of this thing. What I am saying is that you just put this equals to tan theta, and then you convert all into theta only. Like this formula can be converted into theta. So that also you can do, but I am habitual of this thing, that I wrote down the expression 1 plus sigma upon omega epsilon whole square to the power 1 by 4. So this is what I am habitual. I feel that if when you take theta, then there is a chance of getting error, right? When you take theta, because at different theta you can get the same values. So that I want to avoid. I want to avoid inverse trigonometry here. So that's why I am dealing this thing. Okay. So what will be the angle you will be getting? The angle you will be getting is 1 by 2 tan inverse sigma upon omega epsilon. This is the angle you are getting, right? So this was the angle. What was your gamma? Gamma was actually written as alpha plus j beta, or iota beta is my habit, but j beta you should call. Or what was the general expression? General expression was j omega mu into sigma plus j omega epsilon. This was the general expression. What was the value of alpha? Alpha was omega under root mu epsilon by 2, then bracket under root 1 plus sigma upon omega epsilon whole square minus 1, then bracket close, right? And what was your beta? Beta was omega under root mu epsilon by 2, then bracket, then under root 1 plus sigma upon omega epsilon whole square plus 1. This was your beta. This was your alpha, this was your beta, right? So here this was attenuation constant, this was your propagation constant. The unit of this was Nepper per meter. The unit of this is radian per meter. Okay. These are the things. Neta, eta, everything we have written. What else is left? Vp equals to omega by beta. What was your Loss tangent? Loss tangent was tan theta equals to sigma upon omega epsilon. And what was your theta and eta relation? This was the theta and theta eta relation, right? Wherever there is some subscript, 2 will come, right? Let's talk about free space where sigma is equals to 0. So there will be no phase difference. The phase difference will be 0. What was the value of alpha? 0. Value of alpha will be 0, because if you put sigma equals to 0 here, then it will be 0. Or you can see here also, you can see that there is no attenuation. E to the power minus alpha z, that is equals to 1. That means alpha has to be 0 only, right? So alpha was 0. What was your beta? For free space we are going to write down. So omega under root mu naught epsilon naught. So under root mu naught epsilon naught. Under root mu naught epsilon naught. What will be the value of this? Do you remember the value of this? 1 upon under root mu naught epsilon naught. Yes, that was 3 into 10 to the power 8 meter per second. Or I can write down equals to c. This is known as c, the speed of light. This is known as c. Speed of light is known as c. Okay. So what will be this? This will be equals to 1 by c. So can I write down it is equals to omega by c? So beta is equals to omega by c. Beta equals to omega by c. Okay. Here the velocity is equals to speed of light only. And what was your eta here? Eta was simply equals to mu naught by epsilon naught, or you can say it was a constant value which was equals to 120 pi ohm, or you can say it was equals to 377 ohm. What was your Vp? Vp was equals to omega by beta, you can say. Where omega, what was your beta? Beta was this value, or you can say it was equals to 1 upon under root mu naught epsilon naught. And if you solve it, what is the answer you are going to get? 3 into 10 to the power 8 meter per second. What was your theta and theta n? Both were equals to same only, because they were simply, basically for theta and eta you will get 1 by 2 tan inverse sigma upon omega epsilon, and for theta you will get tan inverse sigma upon omega epsilon. Sigma is 0, so both will be equals to 0 degree only. Both will be equals to 0 degree. This is your loss angle and this is intrinsic impedance angle. If there is no loss, the angle has to be 0 degree only. So this is the answer. Lossless dielectric. So here the change is only this. Epsilon is equals to epsilon naught epsilon r, mu is equals to mu naught mu r. That is the only change. So what was the value of alpha? Here also there was no attenuation, 0. What was the value of beta? Beta was omega under root mu epsilon, right? Or you could have written it in this manner, into mu r epsilon r. Or this could be written as omega by c under root mu r epsilon r. If I take mu r equals to 1, which will be happening in most of the cases, in most of the cases they will say it is a non-magnetic material. So they will say that mu r is equals to 1. So if mu r is equals to 1, what is the expression of beta you are getting? Omega by c under root epsilon r. Is that clear? We are just building up the formula more, because this is how we will solve the problem. So we are not learning anything new. Just from this expression, whatever I can get, that I am going to write down. So under root mu naught epsilon naught is equals to 1 by c. So that I have written. Okay. So this is how I am going to proceed. What was your eta? What was your eta? Eta was this thing. Or I can write down it in this manner. Mu naught mu r epsilon naught epsilon r. So what I can take out? Mu naught epsilon naught into mu r epsilon r. So under root mu naught epsilon naught is 120 pi into under root mu r epsilon r. And if non-magnetic material is given, then what will be the expression? 120 pi upon under root epsilon r, if mu r equals to 1 is given. Is that clear to you? Yes. What was your Vp? Vp was omega by beta, or you can say Vp is my simply 1 upon under root mu epsilon, or I can write down in this manner, mu naught mu r epsilon naught epsilon r. So what I can take out? 1 upon under root mu naught epsilon naught separately. So that will be, basically what I am taking out is that 1 upon under root mu naught epsilon naught into mu r epsilon r. So what is the value of this? This is equals to c. So c by under root mu r epsilon r. And if it is a non-magnetic material, which will be happening in 99% of the cases, so the answer will be c upon under root epsilon r. Is that clear to you? So just the new thing is being introduced here, that is under root epsilon r. So eta for free space was 120 pi ohm. Just by under root epsilon r you need to do. The phase velocity for free space was c, but under root epsilon r you need to divide. Here beta, it was omega by c. So under root epsilon r you need to multiply. So this you don't need to remember. Slowly when you solve the problems, eventually you will be able to write down very quickly in the examination. Okay, or you can start from here as well. If you just see this expression, what you will realize, it will be under root mu naught epsilon naught, so divided by r, then mu r epsilon r, directly epsilon r. So this is what I keep in mind. From there I can derive it very easily once I have the practice. Now what we are seeing, low loss dielectric. Okay, the loss is low. Lossy dielectric we have already seen here. The general medium means lossy dielectric only. Lossy dielectric. Lossy dielectric means sigma is finite and a decent value. Certainly our all the mediums will be charge free. Epsilon will be equals to epsilon naught epsilon r and mu will be equals to mu naught mu r. So this is the medium we have seen, which is equals to your lossy dielectric only. टेढ़ा क्यों लिखा जा रहा है? This is lossy dielectric only. Now I am going to see low lossless. Okay, not low loss dielectric. The loss is low. That means sigma is not equals to 0. Sigma is not 0, but it is very low. Okay. So this is what we are going to write down. So these are the equations. Theta n value will be also finite. It will be nearly equals to 0, but certainly some value will be there. So that's why we are writing theta n as also. So E leads H by theta neta or theta n, whatever you can call it. So H naught is equals to, this is the magnitude of H naught, right? Let's write down more formula. So alpha is equals to j omega beta. So forget about it. Let's write down the expression of alpha. What was the expression of alpha for a general medium? This was the expression of alpha. Okay, so forget about beta here. I'm gonna do something. Now, have you studied this thing 1 plus x square to the power 1 by 2? If x is very small, can I write down it in this manner, x square by 2? Basically 1 by 2 can come ahead. 1 plus x square to the power 1 by 2 is there. So if x is very small, let's just say x is 0.01, then its square will be more small, 0.001, right? 10 to the power minus 2. So yeah, 0.0001. So it will be more small. So if it is very small, then can I write down? Really sorry, it will be written down as 1 plus 1 by 2 x square. 1 plus 1 by 2 x square. Is that clear to you? Can I write it down in this manner? Yes. So same thing I am going to do here. So what I am going to do, this is omega under root mu epsilon by 2, then bracket. This is 1 plus sigma upon omega epsilon whole square to the power 1 by 2. So this 1 by 2, 1 plus 1 by 2 sigma upon omega epsilon whole square can come, right? 1 by 2 will come in front. 1 plus 1 by 2 sigma upon omega epsilon square, and then minus 1 is there. So 1 and minus 1 will get cancelled, right? So omega upon under root mu epsilon by 2, then 1 by 2. This is your omega upon mu epsilon whole square. Look, this is the formula which you don't need to mug it up. Just I am telling something, that if my sigma is very low, then what kind of assumption I can make? If sigma is very low, then this can be taken as 1 by 2 and 1 is getting cancelled. And this is under the influence of under root. This is under the influence of under root. So this I can take out. Basically this under root I can remove, and this under root I can keep till this here only, and then I will take this out. Basically this sigma upon omega epsilon can be taken out. Is that clear to you? Very simple mathematics. Sigma upon omega epsilon square is there, so this is the under root I am taking. In the examination we are going to derive all these formulas there. You don't need to mug it up. This omega and this omega is getting cancelled. This is your 2 into 2. 2 into 2. So what will get out? Sigma is already there. 2 into 2 is 4. Under root 4 is 2. So sigma by 2. Now, this is your epsilon and this is your under root epsilon. Epsilon under root divided by epsilon. So what you are going to get? 1 upon under root epsilon. And what else you are having? Under root mu. So this is the expression you are getting. This is the expression of alpha. For low loss, if the loss is pretty low, then this is the expression of alpha. Is that clear to you? So in the examination you are going to write down this formula. Okay, if you are not able to remember it, you are going to write down this formula, then quickly you will see that sir 1 and 1 will get cancelled. This 1 by 2 I can take ahead. If 1 by 2 I am taking ahead, then 1 by 2 into 1 by 2, this will come out. Then omega and omega will get cancelled. Sigma will also come out, and this is epsilon, and here there will be under root epsilon. So downward I will have under root epsilon, and upward I will have under root mu. So this is the expression I am gonna get. If you keep in mind, then it will be pretty good for you. For low loss. What do you mean by low loss? Low loss means sigma upon omega epsilon is very less than 1. It is a very small quantity. Sigma upon omega epsilon is a very small quantity. So 1 plus 0.01 square, you will do something like that. So it will not make much effect, but it will certainly be not be equal to 0. What I mean to say is that if I take this as 0, sigma upon omega epsilon, if I take this as 0, then what will happen? Under root 1 minus 1, that will be 0. So alpha value will be coming 0. So that will become lossless dielectric. But it is neither lossy, it is neither lossless. It is low loss. Lossless, lossy, in between there is low loss. That certainly there will be some attenuation. If your wave is traveling and then this low loss medium is coming, then certainly there will be some attenuation, but the attenuation will be very low. So that attenuation, if they are asking sometimes, so you cannot say that sir attenuation is 0. No, there will be some attenuation, that alpha value. So that can be found by this expression. So alpha is directly proportional to sigma here. It is directly proportional to sigma. So if sigma is very low, then certainly alpha is also very low, right? So this expression, if you want to keep in mind, then you can keep in mind. I actually remember it sometimes. Okay, so because I have been into this for a very long time, so I have the habit to write down this expression. If I get a sigma upon omega epsilon very low, then I will write down this expression very quickly, that your alpha is equal to sigma by 2 under root mu upon epsilon. Okay, let's write down about beta. So what will be your beta? Omega under root mu epsilon by 2, then under root 1 plus sigma upon omega epsilon square plus 1. Now if I take sigma upon omega epsilon equals to 0 here, then there is no issue. What was the issue here? It was becoming 0, which I don't want, because I know it is non-zero value. I know this alpha is non-zero value. But here if I take this nearly equals to 0, there is no issue, because what it will become? Root 1 plus root 1. Root 1 plus 1, that will be 2, and 2 and 2 will get cancelled. So what will be the value of beta you will be getting? Beta is same as the lossless medium. This beta is same as the lossless. So nearly it is equals to, I will write nearly. So nearly this is the answer you will be getting. Here also nearly you will be getting 0. But what if in the option you are getting this thing? 0.079, 0.081, 0.084, 0.093. So yeah, all are nearly equals to 0. So you need to click one option, no? Then you can use this formula. So same goes here. If in the options you are having very large difference, let's just say one guy is saying that value of beta is equals to 22 radian per meter. Other guy is saying that 45 radian per meter, otherwise 90, and then 330. So if these are the four options, then you would know that if I apply this formula as well, then near possible answer I will get. Are you getting this point? And but if I put 0 here, then this will be becoming 0, which is not equals to 0. This will be some finite value. Are you getting this point? So that's why I wrote down this formula. So this is the value of beta you are getting. Let's talk about neta. Let's talk about neta. So your neta was, this was your neta. I am talking about the magnitude. The angle will be given by this expression only, that is 1 by 2 tan inverse sigma upon omega epsilon. So angle will be given by this expression only. There is no doubt about that. Whatever the value of sigma you are having, that you can put sigma upon omega epsilon. Since it is very less than 1, it will be nearly equals to 0. But this is the formula which you can use. What was the other formula we were having? Sigma upon omega square epsilon to the power 1 by 4. Did I write the correct thing here, or I even forgot to write down? Did I write down the value of eta here? Yes, I wrote down the value of eta. Yeah, okay, fine. So here also if I take sigma equals to 0, is there any doubt? If I take sigma upon omega epsilon equals to 0, will there be any issue? No, nearly 0 I can take. If I take sigma upon omega epsilon equals to 0, that also I can take here. Only at this place I cannot take it equals to 0. Why is that so? Because that will make alpha equals to 0. Only problem is with alpha. I know alpha is non-zero value, so that's why I cannot take it equals to 0. Here also I can take it equals to 0. So nearly I will take it equals to 0. So nearly this quantity will be equals to 0. So what will be the magnitude of eta you are getting? The same magnitude which was there for lossless medium. So there is very low loss, that means it is nearly equals to lossless medium only. Just the difference will be in the expression of alpha, which is this thing. So only the difference is alpha. If some medium is low loss, then you can take it lossless medium only. But the difference which you need to take care is that the value of alpha will be non-zero, and that will be given by sigma by 2 under root mu upon epsilon. Is that clear to you? Yes. So how this loss tangent will be given? This is how the loss tangent will be given, which is equals to theta equals to tan inverse sigma by omega epsilon. So I will put the bracket on a lot of points, but what you need to remember is only this thing. Alpha is equals to sigma by 2 under root mu upon epsilon. Beta is this expression which we already know. Neta is this expression which we already know. This expression also we already know. This expression also we already know. And this expression also we already know. Is that clear to you? Yes. For good conductor, here mu equals to mu naught mu r is written. Not this is written mu naught mu r. Okay. Mu is equals to mu naught mu r is written. Not only mu naught. It is mu naught mu r. And more importantly, in a lot of expression, mu r will be equals to 1 only. So that will be given in the question. But since it is not given, let's solve it by our concept only. So here we know that theta neta is equals to 45 degree. So E will lead H by 45 degree, and this is the expression of H naught E naught by eta naught. Alpha is equals to beta only. Here alpha is equals to beta only. So what will be the expression of alpha? Do you remember it? Omega mu sigma by 2. Like generally I am also not confident with this formula. In the examination, what do I do is that I will write down alpha, because in the examination confidence is more important. So alpha is equals to omega mu epsilon by 2. Then I know there will be bracket 1 plus under root something would be coming, and then that I know that it will be replaced by this under root 1 plus sigma upon omega square minus 1. So that will be 1 and 1 will be getting cancelled, under root will be getting this expression. So this and this get cancelled. I am talking about if you are an aspirant. So if you are aspirant, epsilon get cancelled. So within 10 seconds I will be able to write down this formula. If I am not remembering it, within 10 seconds I will be able to write down this formula if I am not remembering it. And what about this? What about this guy? What about gamma? If they are asking gamma, one thing I know that alpha is equals to beta. So this is something I can write down, right? Alpha plus iota alpha. Alpha plus iota alpha or J alpha we can say. Okay. So what I am getting here? Omega mu sigma by 2. This is your alpha. Alpha I can take common, 1 plus J. This is the expression I can get. Okay. If they are asking me the magnitude, then I can write down the magnitude as well. Also, if they are asking me the angle will be 45 degree only. So that also I can write down. Right. So this is the expression of gamma I can write down. Is that clear to you? Fine. What about eta? What will be the expression of eta? So again, I'm gonna write down the general formula J omega mu. Then I know here I will write down sigma plus J omega epsilon. But I know J omega epsilon is very low, so this is what I'm gonna write down. So J omega mu upon sigma. What will be its magnitude? Omega mu upon sigma. Angle will be 45 degree. Is that clear to you? Okay. So it is not tough to remember these formulas, but just you need to have patience, and if you have the patience, then you will be able to remember it. And in the next video we will solve the assignment, it will come more to you. Okay. Loss tangent was this only, right? From there we got the formula of theta, which was tan inverse sigma by omega epsilon, and what was your skin depth, which was 1 upon alpha, right? This was your skin depth. And if you write down the formula of skin depth, then this can be written as 1 upon under root omega mu sigma by 2, or it can be written as under root omega mu sigma. Okay, this is the expression of eta. So these are the formulas. Yeah, here there is assignment. So in the next video we will solve the assignment. You do not need to solve it on your own first. You just see me solving some problems. After that you can start solving it. So next video will be based on assignment. But here, do you see the summary? This is the summary of all the expressions, right? general expressions, angle, then for free space, then for lossless, low loss, and then good conductor. So we are having 5 kind of mediums. What was the first one? Free space, then lossless dielectric, then low loss dielectric, then lossy dielectric, which is known as general medium as well, and then good conductor. Is that clear to you? Okay. So let's revise this formula again, or revise all these formula again, and in the next video we will start applying these formula. Thank you very much. Do not ignore the assignment, because there also there will be some new concept which you might be learning. Thank you very much.